Naming ionic compounds. There are two ways an ionic compound can be formed: joining a metal with a nonmetal and joining a metal with a polyatomic ion. Let's start with ionic compounds that result from a bonding from a metal and a nonmetal. This is a metal with a nonmetal from formula to name. The first thing you need to do is to ask yourself if the metal is transition or a pure metal. Most of them can have different charges. We need to be sure the sort of metal we deal with as well as its charge. Remember, transition metals are the ones in the middle of the periodic table and at the bottom. And the rest of the groups, family 1 will have a positive 1 charge, family 2 positive 2, family 3 positive 3, and so on. This is a table with different charges that different elements can have, and you can see how they can change, especially in the middle of the periodic table. Chromium can have positive 3, positive 2, positive 6, iron positive 2, positive 3, and copper positive 2, positive 1, as an example. Let's start with a metal with 1 charge, not transition or pure metal. NaCl. Remember, the metal will go first and after will go the non-metal because of electronegativity. To name it, we will start with the name of the metal. In our example, Na is sodium. Next, you need the name of the non-metal, changing its ending to IDE. In our example, instead of chlorine, that is Cl, we will use chloride. And the name of the compound will be sodium chloride. Now try this one, KBr. Our metal is K, that is potassium, and our non-metal is Br, that is bromine, and we change the ending to bromide. Putting it together, it will be potassium bromide. Now let's do a metal with 2 or more charges, transition or pure metal. To name it, we will start with the name of the metal. In our example, Fe is iron. However, iron can have a charge of positive 2 or positive 3. Which one is iron using? As you remember, a compound is electrically neutral. So in order to balance the positive and negative charges, we cross out the charges to become number of atoms. In our example, the 3 will indicate a positive 3 charge for iron, and the 2 will indicate a negative 2 charge for oxygen. So iron is using a positive 3 charge, and the way we'll represent it is using a charge in Roman number after its name, so it will be iron 3. Next, you will name the nonmetal, changing its ending to IDE. In our example, instead of oxygen, we will use oxide. And the name of this compound will be iron 3 oxide. Now try this one. Our metal is Cu, that is copper, and the non-metal S, that is sulfur, is sulfide. Copper can work with positive 2 or positive 1 charge, so let's analyze it. First, copper has a subscript of 2 and sulfur doesn't have a subscript. When there is none, it indicates there is a 1 over there. The 2 will indicate a negative 2 charge for sulfur, and the 1 a plus 1 charge for copper. So copper is working with positive 1, and the name will be copper 1. And the total name will be copper 1 sulfide. A special case for you. Our metal, Cr, is chromium, and the non-metal, Se, is selenium, in this case selenide. At first sight, it seems that chromium has a charge of positive 1 because there is no subscript, but this also may indicate that chromium and selenium have the same charge, and it has been simplified. So in these cases, the anchor element, it will be the non-metal, selenium in this case, and as it is in the oxygen family, its charge is -2. So chromium must have the same charge but positive, and that will be +2. Let's take a look. -2, +2. Crossing out these charges, that will be a double 2, that if we simplify them, we will get the same formula. Remember, 1 is not written, and the name will be chromium 2 selenide. Let's continue with ionic compounds that result from a bonding of a metal and a nonmetal, but this time having the name and requiring the formula. So metal with a nonmetal, name the formula. Departing from the name is much easier as they give us a clue if we have a transition or a poor metal because of the Roman number. Otherwise, we can use the charge of the group. Our first example is lithium carbide. Lithium is a metal from the first family, so its charge is +1. Carbide comes from carbon, which is a nonmetal with a charge of -4. Let's put this information together. It will be LiC, +1, -4. Then we cross out the charges. Remember, the 1 is not written. And our last formula will be Li4C. Try the next one, mercury 2 nitride. A metal, mercury 2, that's Hg with a +2. A nonmetal is nitride, comes from nitrogen, and is -3. Putting it in the formula, adding the charges, +2, -3, we cross them out, and presto. So our formula will be Ag3 and 2. Now let's see if you can get this one. Barium oxide. A metal, barium, Ba+2. A nonmetal, oxygen, that is O, -2. Let's put this information together. BaO, +2 and -2. That brings us a 2 and a 2 as a subscript. We can simplify them, giving us a 1. But remember, in chemistry, we don't write the 1s as subscripts. So our formula will be BaO. Now that you know how to name a metal with a nonmetal, let's learn how to name a metal with a polyatomic ion. Remember, a polyatomic ion, there are different atoms joined together in covalent bonding, but working with a charge in an ionic compound. Metal with a polyatomic ion from formula to name. The process of naming an ionic compound of this sort is pretty similar to the one we just learned before. The only difference is that instead of having a nonmetal, you have a polyatomic ion with a specific name and charge. This is a list of the most common polyatomic ions and their charges. Let's start with a metal with 1 charge, no transition or pure metal. To name it, we will start with the name of the metal. In our example, K is potassium. Next, you name the polyatomic ion without changing its name. In our case, OH is hydroxide. Finally, let's put it together, and the name of this compound will be potassium hydroxide. Now try this one. Our metal, Ca, calcium. Our polyatomic ion, NO2, nitrite. Putting it together, that will be calcium nitrite. Now let's do a metal with 2 or more charges, transition or pure metal. To name it, we will start with the name of the metal. In our example, Fe is iron. However, iron can have a charge of +2 or +3. Which one is iron using in this compound? As you remember, a compound is electrically neutral. So in order to balance the positive and negative charges, we cross out the charges to become number of atoms. In our example, that will give us a +3 charge for iron and a -2 for CO3. So iron is using +3 charge, and the way we will represent it is using a charge in Roman number after its name, iron 3. Next, You will name the polyatomic ion without changing anything. CO3 is carbonate. And the name of this compound will be iron 3 carbonate. Now try this one. Our metal nickel, that is Ni. Our polyatomic ion PO4 phosphate. Nickel can have positive 2 or positive 3 charge. Let's analyze it. As watching the subscripts, the 3 give us a charge of negative 3 for phosphate and the 2 a positive 2 for nickel. So it's nickel 2 and the name will be nickel 2 phosphate. A special case for you. A metal CO is cobalt. A non-metal polyatomic ion, SO3 is sulfite. Is cobalt working with positive 2 or positive 3? As we learned before, in these cases the anchor element is the polyatomic ion, SO3, which is sulfite, and its charge is negative 2. So cobalt must have a charge similar but positive, so it's positive 2. Analyzing it, both of them have a subscript of 2 giving a negative 2 and a positive 2 charge. And the name will be cobalt 2 sulfide. Now let's have a metal with a polyatomic ion, starting from the name and getting the formula. As we learned before, departing from the name is much easier, as they give us a clue if we have a transitional poor metal because of the Raman number. Otherwise, we can use the charge of the group. Our first example is magnesium hydroxide. Magnesium is a metal from the second family, so its charge is positive 2. Hydroxide is a polyatomic ion, OH, with a charge of negative 1. Let's put this information together. Because of the charges positive 2 and negative 1, we will cross them out, and that will give us a subscript of 2 in hydroxide and 1 in magnesium, but the 1 is not written. So our formula will be this one. Nitride, vanadium 3 nitrate. A metal, vanadium 3, this is V with a positive 3, and a polyatomic ion, nitrate, NO3, negative 1. Let's put it in the formula. Positive 3 for vanadium, negative 1 for nitrate. Crossing them out, the 3 as a subscript, and the 1 is not written. So our formula will be V parenthesis NO3 parenthesis 3. Thank you for watching.